Go ahead and open up your notebook to page 48. Today we're going to talk about something called geometric sequences. And I know the numbers currently don't make a lot of sense because it's like 13, we had 5. We're actually going to skip ahead to 15 now. It's page 48 and 49 are going to be 15.1, constructing geometric sequences. Understanding geometric sequences. Constructing will be tomorrow, 48, 49. So 15.1. Understanding geometric sequences. So that's 48 and 49. All right, attached to this is a few problems. If you don't have a copier, that's fine. This one's actually easier to do without the copier because you're just going to write down some of the things we have. We are going to also write just in our notebook in a minute. All right, so the first one here, you need to cut them out on the black lines. Here's the first piece. I'm going to glue that in at the top 48. Okay. So we're talking about geometric sequences. We've already talked about arithmetic sequences. And arithmetic sequences were sequences where when we wanted to get from one term to the next, we would add a number or subtract a number. Well, geometric is the same in the idea of we're looking for a common thing, but instead of looking for a common difference, we're looking for a common ratio this time. So let's go ahead and look at some of these examples real quick. So the sequence here, 3, 6, 12, 24, and 48, is a geometric sequence. In a geometric sequence, the ratio of successive terms, the one right after the other, is constant. The constant ratio is called the common ratio, often represented by R. So we will use R to show the ratio. So we're going to complete the division to see what the common ratio is. And when we are looking for common ratio, or the R value in this situation, we're going to be dividing the second by the first. And we'll, of course, do second divided by first, third divided by second, and so on. So 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. That means that the common ratio for the sequence is 2. And you would normally see that as R equals 2. Letter C says, find the common ratio you found to identify the next term in the geometric sequence. So to find out how it went from each of these, we divided. We got that you can multiply 3 times 2 to get 6. 6 times 2 to get 12. So to continue the pattern, we have to find the next term after 48. We are going to multiply by 2. And 48 times 2 is 96. So there's how we would find the next term. All right, some reflect questions. I want you to pause the video and read these and try them. Number 1 says, suppose you know the 12th term in a geometric sequence. What do you need to know to find the 13th term? How would you use that information to find the 13th term? So answer that question. So in order to find that, we would need to know the common ratio. That's the piece that we're missing. Okay, and you would multiply the common ratio by the 12th term. That would give you the 13th term. Okay. Number 2. Suppose you know only that 8 and 128 are terms of a geometric sequence. Can you find the term that follows 128? If so, what is it? Well, the answer is no, and here's why. Up here in the definition of a geometric sequence, it says in a geometric sequence, the ratio of successive terms. No, because we don't know if 8 and 128 are successive terms, meaning do they come right after the other? Now, if they are, then the answer would have been yes, but since we don't know, we have to say no. Okay, now we're going to write on page 49 some examples. So page 49. Find the common ratio, which remember is R, and use it to find the next three terms. So we have to make sure we do both, find R and the next three terms. Number 1, 6, 12, 24, 48. We'll find the next three terms, but first let's find R. So to find R, we take the second term, 12, divided by the first term, 6. Now it says that we already know, or should already know, that this is actually a geometric sequence. If we didn't know, we would have to figure out, hey, are we going to be multiplying by the same thing every time? So 12 divided by 6 is 2. Okay, so 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So that means it is definitely a geometric sequence. Now we need to find the next three terms. So 48 times 2 is 96. 96 times 2 is 192, and you're going to need a calculator probably, because 192 times 2 is 384. So there's both answers. I found the ratio and the common difference. Number 2. 100, 50, 25, 12.5. This is why it is extremely important that you do the second divided by first and don't get it switched up, because notice how this one is decreasing in value. 50 divided by 100 is going to be a fraction. It's going to be either 1/2 or 0.5. Now, it does not matter to me if you use 1/2 or 0.5, okay? But 12.5, to get the next three terms, we have to multiply it by 0.5. And I'm going to get 6.25. And then 3.125. And then 1.565. There's the next three terms. All right, number 3. I'm going to go ahead and write 3 and 4. I want you to pause the video. I want you to try both of them. Number 3 is 5, then 20, then 80, then 320. And number 4 is 5, then 15, then 45, then 135. So you're finding R in the next three terms. All right, now that you have done them yourself because you paused it, R is 20 divided by 5, which is 4. So I'm going to multiply by 4. 320 times 4 is 1,280. 1,280 times 4 is 5,120. And 5,120 times 4 is 20,480. Notice I don't put commas with my thousands because I don't want it to look like it's a different term. So don't put commas in with your thousands right now. Right? Number 4, r equals 15 divided by 5, which is 3. 135 times 3 is 405. 405 times 3 is 1,215. And 1,215 times 3 is 3,645. Okay, last but not least, we're going to do a word problem. So the last piece that you have right here is going to go glued in right under this. So go ahead and glue that in there. I'm going to read the question, see what it says. Now, something that's nice, not necessarily nice, just something you should notice about these, you see how fast these grow? A geometric sequence is actually an exponential function, which is why we're doing it right now. We're going to start talking about exponential functions next week. They grow really fast because you're multiplying by a number. All right, let's look at the word problem. A bungee jumper jumps from a bridge. The table shows the bungee jumper's height above the ground at the top of each bounce. The heights form a geometric sequence. Here's our question. We're going to highlight it. What is the bungee jumper's height at the top of the 5th bounce? That means we're going to have to extend this table to 5. In order to extend this table to 5, since it's a geometric sequence, we're going to have to find the common ratio. That means what happened from the first to the second. Now, we are going to do what we did before. R equals, take the second term, these are the term number, the second term, which is 80, divided by the first, which is 200. It is going down. If it is going down, it should be a fraction or a decimal. If it is going up, it should be a number greater than 1. Okay, and that is 0.4. Okay, so now we're going to multiply. So that means from here to here, we got multiply by 0.4 times 0.4. So to find the 4th and then the 5th, because we're looking for the 5th bounce, so when you go to 5, we're going to multiply by 0.4. So 32 times 0.4 is 12.8. Multiply again, and I got 5.12. Okay? And last, we're going to answer it in the word problem. The bungee jumper's height would be 5.12 feet at the top of the 5th bounce. There we go. All right, tomorrow we're going to talk about how to write the equations for geometric sequences.